Hi everyone. In today's challenge, we are going to solve this problem. The problem name is total cost to hire K workers, and the problem number is 2462. Alright, guys. So as usual, first of all, we are going to clearly understand this problem statement. After that, we are going to move to the logic part. We are going to see how we can solve this problem. What is the logic to solve this problem? And after that, we are going to move to the implementation part. We are going to implement our logic in four programming languages: Python, C++, Java, and JavaScript programming language. Fine, guys. Now let's see what this problem says. Right. So problem says you are given a zero indexes integer array cost where cost of I is the cost of hiring the ith worker. So guys, first thing is clear that we are given one array, right? The array name is going to be nothing but cost only. And let's make some demo array. Let's insert some value 2, 3, 4, 5. And this is nothing but we can say 0 indexes, 1 indexes, second index, third index. So this 4 represent nothing but the cost of hiring the second worker. This 2 represent nothing but cost of hiring the 0th worker, right? This is the simple meaning of first line. Now the second line, you are also given two integers k and candidates. So second input is also going to be integer and third input is also going to be integer, right? It makes sense. We want to hire exactly k workers according to the following rules. So now guys, this second array is k, third array is third array is nothing but we can say candidates, right? So now guys, we want to hire exactly k, we can say worker. We want to hire exactly k workers according to the following rules. So we have four rules here. I hope it makes sense, right? You will first rule is you will run k session and hire exactly one worker in each session. So we are going to run exactly k session, right? And in each session we are going to hire exactly one worker only, right? Okay, and that is mandatory also. You have to hire exactly one worker in the each we can say session, right? So let's make a demo. Let's take example one and let's write this post array. Then we will understand these four rules, right? It will be easier to understand with the example. So we have this first post array 70, 12, 10, 2, 7, 2, 11, 20, and 8, right? So we have this array, right? This is nothing but post array. I hope it makes sense, right? Now we are given case 3. That means we have to run nothing but 3 session, right? And then candidates 4. That means there is 4 candidates, right? Now let's see what they told in the second rules. In each hiring sessions, choose the worker with the lowest cost from the either the first candidates workers or the last candidates worker. Break the tie by the smallest index. Simple guys, they have told us the first candidates worker is nothing but you can see first candidate is 4. So first 4 worker, the last 4 worker. Now we have to choose the minimum one. So which is the minimum? The first four, you can say first four numbers or last four numbers. So you can see guys, we have 2 is the minimum number, right? And which is present in the both first candidates and second candidate as well, right? Now they also told us break the tie by the smallest index. So we have to break this tie by the smallest index. So smallest index is always going to be in the first, right? So this is 0, 1, 2, 3, 4. This is 4. This is 5. This is 6. This is 7. This is 8. You can see guys, 3 is the smallest index. Then 5, right? So we are going to take nothing but this 2, right? So we can say our total is nothing but currently we have taken total is nothing but we can say total cost is 2 only, right? And we have taken from the first candidate. So we are going to remove this one, right? Fine. Now we have this array left. Now again we have to do, right? But first let's see the second rule. So third rule. Third rule is nothing but this. We have don't want to consider this one because we have already understood from this only. They are this is the meaning, same meaning which we have done right now, right? So we have seen the first two rules. First rule is we have to run exactly k session, and in each session we have to hire exactly one we can say worker. The second rule was we have to take either from the first candidates or the last candidates, and if both have a minimum one, so we have to take the minimum index one, right? The third rule is nothing but if they are fewer than candidates worker remaining, choose the worker with the lowest cost among them. Break the tie by the smallest number. Same thing, guys. If there are fewer than the candidates worker remaining, means we have array. Let's say we have this array 2, 4, 6, and candidates was 6, right? So we have to take exactly 6 here, 6 there, right? But we have only 3 elements, right? So what we have to do? We have to hire the worker from this only, right? We have to take the minimum from this array only. We don't now assume the candidates things. We have to just take the minimum from the this particular array only, right? And if there are also the we can say the minimum one, so we have to break the tie by the smallest index. Let's say this is also this is 6, this is 2, right? So here you can see 2 is minimum, so we have to take this 2 only, right? We don't have to take this one, right? Fine. The last rule is nothing but a worker can only be chosen once. Simple thing, guys. We don't need to discuss more here. Just the only one line that if you have already chosen a worker, you can't choose that again, right? You have to remove from the cost array. Not exactly, but in the mind you think you have to think like that we have already removed from the cost array, right? Now guys, what we have to do after this for rules, we have to return the total cost to hire exactly k worker. So what is the total cost we have to spend, or we can say we have to use, or we have to give to hire exactly k worker, right? Fine. So we have already seen this first example. In the first step, we have hired the one first candidates from the first 4 candidates, and the total was 2, right? I hope you are following with me, right? Now what we have to do, we have to hire, we have to decrement this k also because we have already taken one. Now k is left nothing but 2 only, right? So we have to hire two more workers from exactly two more sessions, right? One session is completed. Now the first four candidate is nothing but this one. The last four is this one, right? Which is the minimum? 2 is the minimum. So we are going to take 2, and total is going to be 2 plus 2 is nothing but 4, and we are going to remove 2 as well, right? And now k is nothing but we can say k left only 1. We have also completed one more session. That session left is nothing but 1 only, right? Now first for this one, the second for is also this one. So now guys, what we are going to do? We are going to do nothing but we are going to hire a minimum one, which is minimum. The minimum is 7. So we are going to say 7 plus 4 is 11. We have hired exactly 3 worker, right? So it will become 0. Now k is 0, right? So we are going to return nothing but total cost is 11. You can see output as well. We have 11, right? I hope it makes sense. So this is the simple thing, guys. We have seen the example 1. Let's move to the example 2. In example 2, we have only this 1, 2, 4, 1, right? Simple array, simple post array. And k is 3. That means we have to add exactly 3 workers. Candidate is 3 as well. So candidate is also 3. So first 3. So last is going to remain this one only, right? So now, guys, which is the minimum one? First, right? And this is also minimum. This is also minimum. But we have to add the minimum index one, which is this one, right? So we have to remove this one. We have to add in our total cost. So total is going to be nothing but initially 1. Now again, we have to do this 3 from this side and 3 from this side, right? So there is nothing left. So this is going to be remain same, right? And the minimum is 1 only. So we have to remove this one as well. Total is going to be nothing but now 2. And we have hired 2 person, right? So only 1% need to be higher. So we are going to say take the minimum, which is nothing but 2. 2 is 4. So we are going to return nothing but 4 answer, right? So you can see output as well 4. Simple concept. I hope it makes sense, right? So we have understood the problem statement, not a logic part, but I hope you have understood the problem, what we have to do actually in this problem, right? Now guys, let's move to the logic part and let's see how we can solve this problem, right? It's gonna be really easy. As this is a medium level problem, so logic is not gonna be really hard. Let's go this. So let me write a logic part, and now guys, what we are gonna do now? We are gonna say we have given this array, right? 7. Let's take a bigger example only, but we are not gonna solve completely, but we are gonna understand the logic part, right? So how we are going to solve this? 17, 12, 10, 2, 7, 2, 11, 20, and 8. So this was our array initially. So what we are going to do? We are going to do nothing, but we are going to say we have to hire exactly k, right? K workers, and candidate was 4, right? So what we are going to do? We are going to say this 4 and this 4. Just store in somewhere and tell me the minimum one, and that thing can be done by the priority queue. I hope it makes sense, right? So what I'm going to do? I'm going to say, let's say this is my priority queue first. So Q1 and Q2, right? I hope this is visible to you. My camera should not come over here. Let me make it a little above also, right? So Q is 1 and Q2 is this, right? So I have inserted first 4 in the Q1, 17, 12, 10, 2, and 11, 2, 11, 2, 11, 20, and 8. So this is my 2 priority queue, right? Now what I am going to do, I'm going to say I have to run only loops k times. So I'm going to just write here code as well. Not code, I will say pseudocode for I is equal to 0, I less than k and I plus plus, right? That means it's going to run 3 times, right? On each time I'm going to say just tell me the minimum one, which is the minimum here. Here is minimum 2, right? So Q1 tells that my minimum is 2, right? So my minimum is 2, and here is the few codes come to insert some element in Q. We will discuss later, but I'm going to take the minimum one. So the minimum is 2, and Q2 is also tell me that the minimum is 2, right? Both gonna say the minimum is 2. So we can say, let's say left is telling us 2 and right is also telling us 2, right? Just focus over here, forget about this bracket. Left is 2 and right is 2, right? Now what we are going to do, we are going to check if left is less than right. That means the first one is having a number smaller than the right one, right? Even equal one, because if it is also equal, then also we have to take the first one, because we have to break the type by the smallest index. So if both are equal or first one is smaller, so we have to take the left one, right? So we are going to take left one and we are going to add in our total. So we can say total plus equal to left, and we are going to say remove this from our q1. The q1 has been removed, right? Okay, and we are going to say if it is not the case, then we have to say total is going to be nothing but equal to right, and remove from the q2, right? Simple thing, right? But here q1 is going to remove this too, right? Now once this is removed, we are going to move to the second sessions, and in second session we found that q1 has a less number, right? It is not a 4, but we need a 4. Candidate should be the 4. So we are going to move ahead and we are going to insert 7 also in this place, right? Now we are going to again find the minimum one. So here left is going to be nothing but 7, right? And right is going to be nothing but 2 only. So left is less than right, no. So we're going to go in else condition, and we're going to say total is equal to left plus equal to right. So total initially was 2, right is going to be equal to left plus left is right is 2, so right is again 2, so 2 plus 2, and we're going to remove 2 from the q2. So q2 is going to remove from 2, right? Now the last session is also going to go, but before that we have to insert some element in this queue, right? But here if you will find there is no more element present, right? So it will make simple. This here the third rule applies. In third rule we have given if the if we have a fewer than the candidates, if there are fewer than the candidates worker, then we have to consider this only, right? So we have to find again from this minimum. So left is nothing but remains 7 and right is going to be 8. Is left is greater than right? No. Yeah, it is greater than right. Right, left is 7, right is 8. So we are going to add left in our total. 2 plus 2 plus 7 is nothing but you can see now 11, right? So we are going to return answer nothing but 11 only. So this is the simple logic, guys. We are going to use a 2q priority queue, and we are going to run a loop till k times because we have to have, do the exactly k sessions, and we have to hire exactly each one worker in each session, right? Now let's move to the programming language and implement this logic, right? And this logic we are going to implement in 4 programming language. So first is nothing but we have going to use is Python, right? So first programming language is Python, right? So here first of all what we are going to do, we are going to define 2q, right? So q1 is going to be nothing but empty. Let me write this q1 and q2. Let's say this one, right? So q1 and q2 we have defined two priority queue, and let's say don't do this way. And after that we are going to say left is going to be nothing but and right. Left is 0 and right is length of post minus 1. So this is nothing but tell us that the total we have indexes length, right? After that we are going to say nothing but we have to say result, which is going to be the one answer, right? Now we are going to run a loop for I in range of k. We are going to run a loop till k times, right? In each loop we are going to check while length of our q1, right, is less than candidates. We have seen, right, it should have exactly k candidates, right? It is less than candidates, so we have to insert some into this, and left should be less than equal to right, right? That means there should also be number present, right? Then only we can set q1. It's not like q1 has q1 has only two elements, but we are keep trying to insert the elements into this of the right side as well, right? We have to check also that it should have there also number should be present, then only we can set q1, right? In that scenario you can see, guys, we end up with taking 3 only because there are no more number present, right? So this is the thing, same case. Now what we are going to do, we are going to say if this is the case, so you have to insert q1, which you can say heap q dot, what is this, heap q dot heap o, not heap up, we have to say heap push, and here in this q1 we are going to say insert your what we can say post of left side, right? After that you can say left should be plus equal to 1. That means plus equal to 1, fine. And same thing we are going to do for q2 as well, because q2 is from the backward side. So while length of q2 is less than candidates and left should be less than equal to right, right? If this is the case, then heap q dot heap push, and here in q2 you have to put cost of right, right? And you have to decrement right index because you have already taken that one, right? Now once this is done, we are going to take the minimum one. Simple thing, right? Take a minimum. So we can say minimum from the first side. From the first side is minimum is going to be nothing but we can say q1 of 0 if q1 exists, right? Else we can say, let's say, float of infinity, right? If q is no, 1 is not exists, it is empty, so we are going to say empty, maximum, right? And the second side, from the second side we are going to say, or we can say last side is going to be nothing but q2 of 0, right? If only q2 exit, right? Q2 exit. Else we can say float of infinity, right? If it is not exist, if it is empty, right? Fine. And after that we are going to say if first is less than equal to last, which means nothing but we have to take from the first one, first candidate, right? So we are going to say our total, or we can say result. We are going to use the result. So result is going to be nothing but result plus equal to first, fine. And after that we can say q1, or we can say heap q dot heap o, just remove from the q1, right? Minimum one, fine. Else we are going to say result plus equal to not second, last, and we can say last, and heap q dot heap o, we can say q2, right? After that we can simply return our result. Let's try to run this code and see whether it's working fine or not. Simple thing, guys, right? And as you can see, guys, both are SKS pass. So let's try to submit this code as well. Let's see whether we have done something wrong or not. So okay, you can see, guys, it successfully got submitted. We have successfully solved with Python, right? Now let's move to the next programming language, which is nothing but we can say C++. Let's quickly define two priority queue. So we can say, first of all, let's take a length. So we can say left is going to be nothing but 0, right is going to be nothing but cost of size minus 1, and then we can say result, not int, we have to use a long, right? Long result is 0, and then we are going to use a priority queue. So we can say priority queue int, and here we name a q1, but we have to take minimum one, so we have to use nothing but vector int and greater int, right? Once this is done, we are going to say copy this particular thing. Let me copy this, right? I usually do a lot of copy. Why don't we need to do a much extra work, right? We have to just use here q2, right? Fine. Now once this is done, what we are going to do, we are going to say while, not while, we have to use a for type, right? For int I is equal to 0, I less than k, I plus plus, right? We have to run exactly case session. Here in each session we have to hire, right? For that we have to say while q1 dot size should be less than candidate. If it is less than candidates, that means it need to be insert some elements, right? Only when left is less than equal to right. So we can say right, and here fine. Now once this is done, what we are going to do, we are going to say q1. So we can say q1 dot push, and what we have to push, we have to push post of left, right? And after that we can say left should be increment. Same thing we are going to do for the q2 dot size is less than candidates, and we can say right left is less than equal to right. If it is the case, then what we are going to do, we are going to say q2 dot push posts of right, and here we can say right should be minus minus, right? After this while loop, we are going to take the minimum one, so we are going to say uh, int we can say int, and the first candidate side minimum is going to be nothing but candidate, not candidates. We can say first of all let's give us something, right? So we can say integer, or we can say directly int max, right? And same thing we are going to do for seconds or last side. Why I'm doing this will let you know, right? Int max, right? So guys, now we are going to say if q1 is, if q1 empty, right? If q1 is empty, so what we are going to do, if q1 is not empty, so we are going to first should be equal to q1 dot top, right? But if it is not, if it is empty, then it's only by default going to take value int maximum, right? Same thing I'm going to do for here. If q2 empty, right? q2 empty, so we are going to say take int max value by default. But if q2 is not empty, so last should be equal to, we are going to say q2 dot top, right? I hope it makes sense. After this we are going to say if first is less than last or equal to last, so we are going to say result plus equal to first, and we are going to remove from the q1, so we can say q1 dot pop. Same thing we are going to do here, result plus equal to second, not second, last, and q2 dot pop, right? After that we are going to return our result. So let me just do here and return my result. Let's run this code and see whether it's working fine or not. And I hope guys it should also work, right? So let's see. You can see both the test case passed. So let's try to submit this code as well, and I hope it will also get submitted. It's in C++, right? So you guys can see that it successfully got submitted. Now let's move to the last, not last, the third programming language, which is nothing but Java, right? In the Java, what we are going to do, we are going to say int first of all left, which is nothing but equal to 0, and right, which is nothing but equal to post dot length minus 1, and here we are going to say for int I is equal to 0. Before that we define two priority queue, right? So for two priority queue we are going to say q, right? Q, and we can say integer data type. Here we are going to say our q1, which is going to be nothing but new priority queue, right? And here we are going to say fine, and we are going to copy this again, and we are going to say nothing but, not here, we are going to say, let me do here, right? Here we are going to say q2, right? We have defined two empty priority queue, and here we are going to find say long result, which initially 0. We are going to say for int I is equal to 0, I less than k, I plus plus. Here we are going to say if, not if, we are going to say while q1 dot length, q1 dot size, right? Q1 dot size is less than candidates, and q1, not q, left is less than equal to right. So if it is the case, then only you have to insert in q1 dot offer. What you have to insert? You have to insert post of left, and after that you have to say left should be plus equal, right? Same thing we are going to do here. While q2 dot size is less than candidates, and left is less than equal to right. Right, here we are going to say q2 dot offer post of right, and here we are going to decrement right minus minus, and after that we are going to say, so we are going to say here if our, not here, we have to take a minimum one from left, from q1 and from q2, right? So we are going to take say initially our what we could say, we could say first is going to be nothing but q1 dot not q1, we can say integer dot, here what we could say mean value, right? Same thing we are going to do for last, same integer dot mean value, right? Now we are going to say if our node q1 dot empty, right? Q1 dot is empty, that means if our q1 is not empty, so we have to take minimum from this as well. Otherwise by default it's going to take a, not mean value, we have to use a max value, right? Otherwise it will always get selected, right? If q1 is empty, so what we are going to do, we are going to say first is going to be nothing but q1 dot what we could say, we could say peak, right? And if here one more, if q1 not q2, if q2 is empty, then what we are going to say, we can say last is going to be nothing but q2 dot peak, right? So let me write peak. Fine. And here we are going to say if our first is less than last, if first is less than or equal to last, so we are going to say result plus equal to first, result plus equal to first, and from Q1 do the pole, means remove the smallest one. Else we are going to say result plus equal to this last, and we can say Q2 dot pole, right? Fine. And after that we are going to return our result. Let's see whether we have done something wrong in this or not. Okay. So let's see with the Java. And you can see guys, both the test case passed. So let's try to submit this code as well with Java, right? And I hope also it should also get submitted, right? So you guys can see that Java code also got submitted. Now let's move to the last programming language, which is nothing but JavaScript. Why I am clicking on I icon? Okay, fine. Now guys, what we are going to do? We are going to first of all define a priority, right? Before that, let's take a length. So left is going to be nothing but initially 0, and right is initially going to be nothing but post dot length minus 1. Fine. And then we are going to define a priority queue. So we can say min priority queue, right? So const q1 is going to be nothing but new min priority queue. I don't know much about it, but yeah, I hope it should write. Const q2 is nothing but new min priority queue, right? And after that we are going to say let result initially 0, and here we are going to say nothing but for let I is equal to 0, I less than k, I plus plus, right? Here we are going to say while our q1 dot size is less than candidates and left is less than equal to right, so we could say what? We could say q1 dot insert. You have to insert what? You have to insert nothing but post of left side, and after that you have to say left should be plus plus. Same you have to do for while q2 dot size is less than candidates and left is less than equal to right, right? And here we can say q2 dot insert post of right, and you can say right minus minus. And here what you are going to say, you can say initially left first is going to be nothing but infinity, and also right is also going to be nothing but infinity, right? After that we are going to say nothing but if, not if, yeah, we can use if as well. If q1 not equal, no, if q1 dot is empty, then we are going to say we can say first is going to be nothing but equal to q1 dot top, right? Not top, we can use front, or we can use something like this, right? And same thing we are going to use if not. We are going to check it if it is wrong, because first JavaScript is newly language for me, right? And here we can say last is going to be nothing but equal to q2 dot front, right? Okay, now what we are going to do, we are going to say if first is less than equal to last, if first is less than equal to last, so we are going to say q1, not q1, we are going to say result plus equal to first, right? And q1 should remove it, right? So q1 should remove this particular thing. So what we can use for removing the part, we can use dq, or we can say right? We will check it, right? Don't worry about that. Okay, and here we can say last, else we are going to say result plus equal to last, and here we can say q2 dot pop, right? Fine. Now after that we are going to return our result. Let's see whether it's working fine or not, right? So I hope it should work, right? But it may give an error because we don't know what is top, right? So left is equal to right, so this is right, and which is not the case, so we can say right rigst, and we are using something wrong. What is the case? So it says that error can't slash right before that. So let's do this, right? Let rigst. So what's the wrong over here? Okay, this right is not has been initialized, so let's try to run this again. I think we have done something wrong over here. Okay, so rigst let right is equal to this, while q size and left, it's in the connect access right before initialization, so we have done something wrong over here. So right is not this rigst, rigst. Let's copy over here and let's paste this also. Do I'm doing something wrong over here. Left is 0, right is equal to post dot length minus 1, and const this, right, can before initialization. So we have to initialize something. We have already initialized this post dot length, right? So we have done something wrong over here. We are going to check that particular things as well. So okay, let's see, cannot access right before initialization, so we have done something wrong. Const length. Fine, this is cool. RAGST, RAGST. Okay, this is also not the case. So if I say something like this, so we are debugging it, right? So still it's not working, right? So why it is the case, we don't know. Let's do something here, right? Left is getting used, but right is not, right? So if left is less than equal to right, then only we have to do right. So we are going to say length is this, length is this. So cannot initialize before the right. So left is this, left plus plus, right minus minus, right is this. So it should work, right? Right, we are not using it somewhere. That's why it's also correct this one, right? So we could say something if we are using it first, last. Okay, so we have done something over here. Last should be here, right? Now let's run this one. Finally we have seen these things. Now we got a one more error, that is nothing but q1 dot insert is not a function. Q1 insert is not a function, so we can say this is a function, right? If it is not so, we are going to move to that new tab and we are going to check it, but we are going to solve with this JavaScript as well, right? So finally it's also not a function, so we can do something else as well here. So just let me go to the new website. So just give me a second, guys. So I'm going to browsers and I'm checking just with this one. So yeah, we found two things. So the first thing is nothing but enqueue. So we can use an enqueue as well, and we can use a dequeue as well, right? So enqueue, QUE. Fine, is this spelling fine? Enqueue, UE. Let's check it is working fine or not. Hopefully it should also work, right? So we got a one more error, that is candidates. Candidate is not defined. Candidates. So we have to use the candidates, right? So really sorry for this, guys. I have a really less hand in JavaScript. Fine. So this for we have to use a DQ, right? DQ, DEQ, UE, right? Let's run this code, right? It's working fine. Just the only one thing is nothing but we can say expected return type. Right? So we are using a result, but we are returning unexpected return type. It should be long, right? So it should be long. So what we could do, we could say length. Why I'm facing this much error in JavaScript, but yeah, it's looking interesting, right? So we are going to see is not a valid type for the expected return type long, right? So we have to return result. We're returning a result, right? And result is nothing but this one is zero initially, fine, and it's keep adding, right? First is this last, and second is going to be nothing but this, right? So we have don't have to use this front. We have to do something else, right? So what we could do, think about this front. After that, we have to use something which is nothing but we can say element, right? We use a element, and let's run this. I hope now it should not give an error. You can see finally we have passed both the test case. Let's add some this for as well. So finally we are come up with this thing, right? So you guys can see that we have successfully submitted with JavaScript as well. I hope you find this useful. So we have understood the problem understanding part, we have seen the logic part, we have seen the implementation part. So guys, if you have any kind of doubt in this part, you can write in the comment section. I'm always there to help you. And if you learn something new in this video, don't forget to hit the like button and subscribe my channel. Meet you in the next video.